Hi, I'm Miss Ginsburg with KnowAtom, and today we're going to be reading Changing Environments. This is a lab manual in Unit 7. Section 1, Monitoring Ecosystems. Using dogs to sniff out mussels. Popeye is a 7-year-old chocolate Labrador dog. Popeye lives in California, and he has an important job. He has been trained to find mussels attached to the hulls of boats. Mussels are animals that have an outer shell made up of two hinged parts. Zebra mussels and quagga mussels are two kinds of mussels. They attach themselves to rocks or other hard surfaces like boats. When boats move from one waterway to another, they can carry the mussels with them. Finding and removing mussels. Popeye's job is to find mussels attached to boats before the boats enter a new waterway. He is part of a growing trend to use dogs that can sniff out zebra and quagga mussels on the surface of boats. Popeye runs around a boat and sniffs. When he smells mussels, he sits to tell his owner he found them. People can then remove the mussels from the boat. This is important because these mussels can cause a lot of damage to an ecosystem. An ecosystem is a community of different species that depend on interacting with each other and their physical environment for survival. All ecosystems include living things that must eat one another for energy and nutrients. They also include oxygen and carbon dioxide from the atmosphere, water, and energy from the sun. An ecosystem can be as large as an ocean or as small as a pond. Regardless of its size, all the parts of an ecosystem work together to make a balanced system. Mussels harm ecosystems. Zebra mussels aren't native to North America. This means their presence in US and Canadian waterways isn't natural. Human activity brought them here. Zebra mussels were first introduced to the Great Lakes by ocean-going ships that arrived from Europe in the late 1980s. The 5 Great Lakes, located on the US border with Canada, are the largest source of fresh water on Earth's surface. When they first arrived in the Great Lakes, the zebra mussels had no predators. Predation is an interaction occurs when one organism, a predator, eats another organism, prey. Every ecosystem has predators and prey. In a balanced ecosystem, predators and prey act as checks on one another so that no one population of organisms becomes too large. A population is all of the members of a species within a particular area. No natural predators. With no natural predators, the population of zebra mussels exploded. There are now millions of zebra mussels living in the Great Lakes. They grow in massive colonies, and up to 700,000 zebra mussels have been found in 1 square yard of surface area. All of these mussels require food because food provides animals with the energy they need to grow and develop. Changing food webs. Zebra mussels are filter feeders. Filter feeders are marine animals that gather energy by straining nutrients and small organisms out of the water. Zebra mussels strain phytoplankton from the water. They eat so much phytoplankton that they disrupt entire food webs. A food web is a visual that shows the network of food chains in an ecosystem. Food chains show specific paths that energy travels as one organism eats another. Phytoplankton are primary food sources for many of the Great Lakes food webs. All energy in a food chain begins with the sun. As the sun shines, it produces light energy. Organisms called producers capture energy directly from the sun to make their own food. Phytoplankton are the most common producers in the Great Lakes. Producers carry out the process of photosynthesis to turn sunlight, water, and carbon dioxide into oxygen and a sugar called glucose that holds chemical energy. Producers always make up the first level of any food web because they are the link between the energy source, the sun, and the rest of the organisms that live in the ecosystem. Consumers in a food web. The next levels of a food web are made up of consumers. Consumers are organisms that eat other organisms for energy. All predators are consumers. Consumers can be herbivores, animals that eat only plants, carnivores, animals that eat other animals, or omnivores, animals that eat plants and other animals. There are three different levels of consumer. The second level of a food web consists of a kind of consumer called a primary consumer. Primary consumers are the first organisms that get energy by eating producers. Many primary consumers are herbivores. Zebra mussels are primary consumers because they eat phytoplankton. The third level of organisms in a food web consists of secondary consumers, which eat the primary consumers. In the food web below, the fox is a secondary consumer because it eats chipmunks and hares, which eat producers. In some food chains, there is a fourth level, which is made up of tertiary consumers that eat secondary consumers. Mountain lions are tertiary consumers because they eat foxes, which eat chipmunks, and hares, which eat grasses and plants. Decomposers are their own level in a food web. Decomposers are organisms that break down organic waste and feed on the nutrients. When decomposers feed on the nutrients, they are also accessing some of the energy that is stored in the organic matter. As organic matter decomposes, the nutrients within it, including nitrogen and carbon, are recycled back into the environment. Plants can access these nutrients and use them as building blocks to help them grow. Disrupting the flow of energy. When zebra mussels eat most of the phytoplankton, they leave less food for native species that also eat phytoplankton. They're able to outcompete many of the native species. Competitive interactions between organisms occur whenever two or more organisms require the same limited resource. When native species cannot get enough food, there are ripple effects throughout the food web. The entire flow of energy within the ecosystem becomes disrupted. Because they are non-native species that disrupt the flow of energy within an ecosystem, zebra mussels are an invasive species. Positive effects of zebra mussels. Some organisms benefit from the presence of the zebra mussels. Some parasites survive by living on the mussels. In a parasitic interaction, the parasite depends on another living organism, its host, and survives by taking the host's nutrients. Zebra mussels have also helped to filter out pollutants from the water as they strain nutrients, making the water cleaner. However, most people agree that invasive zebra mussels cause more harm than good. They make ecosystems less diverse, with fewer kinds of organisms able to survive. This can affect people as well, especially those who depend on fishing for their livelihood. Zebra mussels also clog pipes because they grow in such large colonies. Getting rid of existing mussels is challenging. It is expensive and time-consuming. This is where Popeye and other mussel-sniffing dogs come in. Their job is to detect mussels before they invade a waterway so they don't get the chance to disrupt the local food webs. Section 2, Energy and Matter, Gulf of Mexico oil spill. One of the largest marine oil spills happened in 2010 in the Gulf of Mexico. An oil rig called the Deepwater Horizon exploded and sank. This caused oil to gush into the ocean for 87 days. 11 people died. Estimates put the amount of oil spilled at 4.9 million barrels, equal to 210 million gallons. The spill was devastating to the Gulf's diverse ecosystems. These ecosystems include coastal wetlands, underwater canyons, ocean water, and freshwater from rivers in the United States and Mexico. Killer whales, shrimp, oysters, migrating waterfowl, and deepwater coral all live in the Gulf of Mexico. More than 6,000 birds, 600 sea turtles, and 100 mammals were killed as a result of the oil spill. Long-term effects of Deepwater Horizon. Scientists are still trying to figure out the long-term effects of the oil spill. The complex interactions between all of the living things in the Gulf of Mexico and their environment make it difficult for scientists to fully understand the long-term effects of the spill on the ecosystem. Ecosystem disturbances. Any event that changes conditions in an ecosystem is called a disturbance. There are many kinds of disturbances that affect ecosystems. Fires, floods, volcanic eruptions, and extreme weather such as drought and tornadoes are all disturbances. These events can lead to shifts of resources within an ecosystem. They can also affect the populations of organisms that make up the ecosystem. How energy flows through an ecosystem determines which organisms will live and which will die. Because of this, a change to the ecosystem that removes an energy source will have a ripple effect throughout the ecosystem. This is similar to how the introduction of an invasive species impacts all levels of the food web. Oil spills. One particularly harmful disturbance is massive oil spills. These are usually a result of human energy production. Oil spills are often the result of accidents that occur when crude oil is being stored or moved. Most oil spills on water will float on the surface. As it spreads out across the water, it becomes very thin, forming a layer called a sheen that often appears silver or gray. Depending on the circumstances, oil spills can be very damaging to the ecosystems. Oil sheen can prevent plants from carrying out photosynthesis. It does this by blocking sunlight from plants that live in the water. Because plants form the basis of most marine ecosystems, those species that eat the plants will not have a food source. Without food for energy, they will die. This change will move up through the levels of the food web. The importance of photosynthesis. When a plant captures light energy from the sun and carries out photosynthesis, it uses 90% of the energy to perform all of its life functions. This leaves 10% of the energy to get passed along to consumers. Because primary consumers only get 10% of the energy, they must eat more plants to get enough energy to perform all of their life functions. When a secondary consumer eats a primary consumer, only 10% of this energy gets passed along. The decreasing amount of available energy as you move up a food web explains why there are fewer organisms at the top of the food chain than at the bottom. Energy gets passed along in the form of chemical bonds holding together the molecules of glucose. Each cell in every living thing takes the glucose and performs cellular respiration in its mitochondria. Remember that cellular respiration is the process in which cells extract energy from food. Oxygen is used to break down the glucose so its energy can be stored in molecules of ATP. ATP is the molecule that powers life. In addition to ATP, cellular respiration also produces heat and carbon dioxide as byproducts. The transfer of energy from one organism to another explains why energy moves in one direction through an ecosystem. It also explains why life requires a constant supply of energy from the sun. Cycles of matter. Unlike energy, matter cycles through ecosystems. Most of the matter that is on Earth today has been around since the planet first formed. Over the years, all of the molecules that make up all of matter, including carbon, hydrogen, oxygen, and nitrogen, have been broken down and transformed as they move through food webs. Matter is transferred and recycled at every level of a food web. For example, photosynthesis and cellular respiration contribute to the oxygen cycle. The oxygen cycle is a back and forth exchange of oxygen and carbon dioxide between plants, animals, and the environment. Plants take in carbon dioxide from the atmosphere. They need it to carry out photosynthesis. They produce oxygen along with glucose as a result of photosynthesis. When animals breathe in, they take in some of the oxygen molecules from the air. When animals breathe out, they release carbon dioxide into the atmosphere. The cycling of carbon molecules. Carbon molecules are also cycled between plants, animals, and the environment. In the atmosphere, carbon bonds with oxygen to form carbon dioxide. When plants take in carbon dioxide to perform photosynthesis, some of the carbon atoms are used for growth, becoming part of the plant. Animals that eat plants absorb those carbon atoms. When plants and animals die, decomposers break down the carbon atoms and return them to the environment. The carbon atoms can be taken in by plants to help them grow. Section 3, Designing Solutions. Shoreline reef balls. For the last 2 years, Jennifer Mattei has visited a section of Connecticut's coastline. She checks on hundreds of giant concrete structures called reef balls that line the coast. Jennifer is taking notes on how well the reef balls are reducing erosion, the transport of sediment by wind or water to a new location. She also wants to see whether any organisms are making the reef balls their new home. A disappearing coastline. For years before Jennifer got involved, the coastline was losing large amounts of sediment through erosion. Scientists believed that the coast had lost sediment up to 1.2 meters deep and 30 meters high. One reason that erosion had become such a problem was the disappearance of oyster reefs. Oyster reefs are structures formed by generations of oysters settling on top of one another. The reefs have disappeared for many reasons, including over-harvesting by people. Oysters have been called ecosystem engineers because their reefs provide many ecosystem services. An ecosystem service is any positive benefit that an ecosystem provides to people. Oyster reefs maintain a tidal exchange by allowing the movement of water between the shoreline and the ocean. Oysters are also an important part of the marine food web. They are primary consumers, filtering plankton and algae from the water. They are a food source for hundreds of species of fish, birds, shrimp, and crabs. Their reefs are also habitat for many of these organisms as well. Their disappearance has had a ripple effect across the food web, causing fewer organisms to survive. Waves in the ocean. The final benefit that oyster reefs provide is shoreline protection from erosion. They do this by absorbing wave energy as the waves move over them. This means that by the time the waves reach the shore, they have less energy. Without the presence of oyster reefs, the coastline was eroding at a fast pace as waves hit the land with their full force. Wind versus tidal waves. The most common waves are those caused by wind. As the wind moves, it transfers some of its energy to the water. This causes surface water waves. Some wind waves are small ripples across the water. Other wind waves can reach 30 meters or 100 feet high. Tidal waves are different from wind-driven waves. Tides are the alternating raising and falling of the sea with respect to the land. They are caused by the gravitational pulls of the moon and the sun, as well as inertia as Earth rotates. Coastlines experience 2 high tides and 2 low tides every day. As the water moves up the coastline and then back, it erodes some of the rocks and sand as it moves over them. Both kinds of waves cause erosion because they carry kinetic energy as they travel through the water. As the waves collide with the land, they transfer some of their energy to the coast. The stronger the wave, the more energy it transfers to the coast and the more erosion it can cause. In response, many towns and property owners have built seawalls to protect the coast from erosion. A seawall is an engineered hard structure designed to protect coastal areas from erosion. The seawall blocks the waves and keeps them from reaching the coastline. Action-reaction forces. When the waves hit the seawall, they exert a force on the seawall. In response, the seawall exerts the same amount of force on the water. This is because for every action, there is an equal and opposite reaction. Action-reaction pairs occur whenever 2 objects or substances come into contact with each other. These action-reaction forces are what cause the waves to crash into the seawall and then back toward the ocean. Seawalls can actually increase erosion because they reflect waves back towards the ocean. Because they redirect the wave energy toward nearby coasts, they speed up erosion all around the wall. Living shorelines. In recent years, engineers have been looking for alternatives to the hard structure of a seawall. This is where Jennifer Mattei and scientists like her come in. They have been exploring living shorelines, which are engineering solutions that use elements of natural habitats to maintain biodiversity and ecosystem services by reducing erosion and providing critical habitats for the wildlife. Some engineers look to natural oyster reefs for inspiration. Engineers have designed artificial structures offshore that provide some of the ecosystem services provided by oysters. Artificial reefs. One common solution involves artificial reefs. Engineers take a hard material, such as fossilized shells, limestone, or concrete, to use a platform that oysters' larvae can attach to. Some places have experimented with used tires. Over time, oysters and other organisms that attach to the surfaces cover the hard material. This draws in small fish and other animals that are looking for food and shelter. Reef balls are a solution. The reef ball technology also creates a living shoreline because each ball becomes a habitat for a wide range of marine organisms. The presence of algae, barnacles, and oysters is one of the things that Jennifer looks for as she walks up and down the coastline. The reef balls also help to reduce erosion because they slow the momentum of the waves hitting the land. Momentum is the measurement of an object's mass multiplied by its speed. Before the water collides with the coastline, it has momentum that depends on its mass and the speed at which it's moving. An object's momentum decreases when energy transfers out of it. This goes back to the conservation of energy. Remember that energy is never created or destroyed. This means that if energy is transferred out of an object, it will have less energy to transfer during a collision. The design of reef balls. Reef balls have holes that water can pass through and come ashore. As the water passes through each hole, some of its energy is transferred to the reef ball. This reduces the wave energy and slows the wave's momentum. Because there is less energy in the water that reaches the shore, sediments can settle, reducing the amount of erosion that takes place. The reef balls are working. In Connecticut, a layer of sediment about 0.3 meters or 12 inches thick has returned behind the reef ball barrier. What causes tides? Understanding tides begins with gravity, the attractive force produced by all matter. Because oceans are liquid, they respond to gravity more dramatically than solid land does. As a result, the moon's gravity pulls oceans toward it. The sun's gravity impacts the tide as well, but with much less force than the moon. The moon is close enough to Earth that its gravity pulls the ocean's water towards it on the side of Earth closest to the moon. This creates an oceanic bulge on the side of Earth closest to the moon. On the other side of the Earth, the moon's gravity isn't strong enough to pull oceans toward it. The second oceanic bulge occurs because of inertia, which is caused by Earth's rotation. Inertia is the tendency of an object at rest to stay at rest, and an object in motion to stay in motion unless acted upon by an outside force. Simply put, objects tend to keep moving or remain still unless they encounter force. As Earth spins, the oceans move with it. Inertia causes the oceans to attempt to keep moving in a straight line away. In the same way, your arms want to move away from your body when you spin around quickly. This causes water to bulge outward on the side of Earth's opposite to the moon. The two bulges of the ocean remain in line with the moon as Earth rotates around its axis. As a location passes through the fullest part of each bulge, the seawater is at its highest level. This is called high tide. It happens twice a day because Earth rotates through each bulge once a day. When the location is at the midpoint between the bulges, seawater is at its lowest level. This is called low tide. It also happens twice a day. Well, I learned a lot reading Changing Environments, and I hope that you did too. I'll see you tomorrow with another book. Bye.